Hello and good day everyone. Welcome back to my channel. Just kidding. So welcome back to EBA 104. So for today's lecture, we will be discussing about beam design. So there are three separate video I created for this topic. So first is this video in which we will discuss about flexural stress and shearing stress. And the next video I will discuss about reinforced concrete beam, how to design it. And the last video is for I-beams, in which the I-beams is a steel. So in this video, we will be discussing only the flexural and shearing stress, and we will consider that the beam is homogeneous. So it is applicable in designing a beam in which the beam is timber. So we will discuss it, how to design, and I separate the example video for these some problems, then you can watch that after you watch this video for discussion about the principle of this. Okay, so let's get started. So beam design. So let's start with uh, definition of what is a beam is. So a beam is a structural member that is subjected primarily to transverse loads and negligible to axial loads. Okay, as you recall, there are lots of beams that are being presented during our previous courses. So in engineering mechanics 1 and also in formal bodies. So maybe you understand what is transverse loads and axial loads. So for the benefits of others, we will review that. So we will have here, for example, this is a beam. So transverse load is, if this is the beam, all the load is being applied here. So axial load is being applied here. So most of the time, all the loads is being applied here. So negligible siya sa axial load. So that is the beam. But some beams like cantilever present an axial load. But most of the time, beams are only transverse loads lang ang naka-apply sa iya. Okay, so transverse load can cause internal shear, forces, and bending moment to beams. It's very common, no? It will result, if this is a transverse load, it will results to internal shear, force, and bending moment. So I have an illustration here. So for example, you have this beam here. So this is the transverse load. It will result to internal shear and stress, and it will also result to a bending stress. Okay, let's start with bending stress. When a beam is subjected to an external load, it creates a bending moment which causes the outermost fiber to be shortened or lengthened. Okay, so very common na siya, no? I think na-discuss siya sa previous topic, sa review of engineering mechanics principle about sa flexural. So, okay, I will discuss lang. Okay, so if this is a beam, if you have this load, so again, we will consider the beam is not rigid anymore. We will consider the beam now that it is deformable, so it will deflect. Okay, so it will solve deflection. So this deflection here, this is the deflection. Then it will, at this fiber, at this part, the fiber will tend to compress, and this outer part here, it will experience tension. Okay, so that's the very basic na phenomena na mahitabo if ever nga natay load nga gi-apply sa atong beam. So, with that phenomena, derive bending stress. Okay, so I will not show the derivation of this formula. I think you already know. So this is the bending stress formula. So you have FB is just equal to my over Ix. Y is the distance at any point from the neutral axis. Yung sa neutral axis, that axis is wala siya na compress, then wala pud siya tension. So neutral. Okay, so to calculate the maximum bending stress, we have this formula here that the F max or the maximum bending stress is MC over Ix. Okay, we substitute Y to C. And we C is the distance from the neutral axis going to the outermost fiber of your beam. For the cross-section siya. Okay, so from derivation, we will have this formula here that the moment is just over the Sx, in which Sx is the section of modulus. So I have here the meaning of that variable that being used in the formula. So we have M, it's the beginning moment, Y is the perpendicular distance, Ix the moment of inertia, because X is the relaxation modulus of cross section. Okay. The equation is valid as long as the loads are small and the material remains linearly elastic. Okay, as you recall sa stress and strain diagram nato na once maubay siya sa Hawk's law, nalang siya sa elastic region. So that's the very important reminder nga inyong i-take note. No? As long as mag-remain he obey the linearly elastic region. Next, shear stress are usually not a controlling factor in the design of a beam except for the following cases. The beam is very short, so it's very applicable in timber design because most of the time when we design a beam that is a timber, as much as possible ato siyang dili siya nato siya ipatagas. So as long as ato yung gamiton is kanang mugbo lang, dili ka siya kayo the property of the material itself. So there are holes in the web of the beam. The beam is subjected to a very heavy concentrated load near the support, then the beam is scooped. That's why I have separated the video for designing sa reinforced concrete and steel beam because I know that there are some formula na pwede siya magamit but applicable gini siya for this part here for designing a beam in which the beam is a timber. So for shear stress, we have FB equals to VQ over IB, in which V is the shear stress at the point of interest, vertical shear force at the section under consideration, then Q is the first moment. Okay, I will show you how to calculate this Q. Then I is the moment of inertia, then B is the width of the cross section of the rod. Okay. So let's derive the formula for derivation of formula for rectangular beam. Okay, recall that bending stress is just equal to MC over I. Okay, then I is just for rectangular cross section, we have BD cube over 12. Then C is the distance here plus it's the distance from the neutral axis going to the outermost fiber. So it's D over 2. Then by simple substitution, you can derive F, the maximum bending stress for rectangular beam is 6M over BD squared. Okay, why is it I show this one? Because sometimes you can not you can be you can use directly this formula. Dili na ka magamit ani, you can directly use this. So if you remember, it's a rectangular beam. So for bending stress, I will use 6M over BD squared. Okay, and then another formula for bending stress is the moment over the section of modulus, in which section of modulus is BD squared over 6. So it's really important to familiarize this formula because it makes mapadali ang pag-solve sa mga problem. If you have ever naman. Okay. So for shearing stress, okay, so this is the formula. V is equals to VQ over IB, which V is the shearing stress, shear force, sorry. Then Q is the first moment of inertia. Okay, let me show you how to calculate this Q. If you have this cross section here, then this is the neutral axis. This is the neutral axis. If we will consider this part here, this B1. Okay, so for this part is BD over 2, right? Because the total area is B times D. So if you divide it by 2, that's the area for this part. You multiply its perpendicular distance from the center of this part here going to the neutral axis. So D over 2 is the distance from the middle to the outermost. So half of this is b over 4. By simple substitution and multiplication, you can calculate that the first moment of inertia of this part here is bd squared over 8. Okay? Then the moment of inertia is bd cubed over 12 for rectangular. So by simple substitution, you can derive that the maximum shearing stress for rectangular beam is 3v over 2a. A is the area in which b of base times that. Okay, so yes, I just show this formula no, just for you to familiarize to if ever nga mag-solve mo, mas mapadali siya makita niyo nga rectangular beam siya, you can automatically use this formula for what. So I challenge you to what if your the cross section of your beam is circular or triangular. So I challenge you to derive the formula here, or if you don't want to be challenged, you can search for that because I did not attach the derivation for that formula. But who knows, the near future, you will masugatan na ninyo siya. Okay? So, I created a separate video to show some of the examples that we can use the formula being discussed so that you can understand very well. So I think that's all. So see you in the example video. Watch that, and after you watch the example video, let's discuss the designing of the reinforced concrete beam. Thank you.